The next few lessons are going to look at some coordinate geometry to do mostly with straight lines, with the equations of straight lines, gradients, and this first lesson on length of lines and midpoints, or lengths of line segments. It's important to make that distinction. We're talking about a line segment between 2 points as opposed to a line with an equation which goes on forever, which has infinite length. There are formulae for finding the midpoint and the length of a line segment, which we need to both know and also know how to apply. So to start with, we have 2 points here, A at -2, -2, and B at 1, 3. To find the midpoint, M, we need to average the endpoints. We can see that the x points we've got are -2 and 1. So if we add them together and average them, divide by 2, we get -1/2. So that gives us the x ordinate. To find the y ordinate, we look at the two y values, we add them together, find the mean, and we get 1/2. So the formula for the midpoint of AB, where that's the line AB, or the line segment, if we give general points here, so xy and xy, we'll call this xy coordinates x1 and y1, and then to make it distinct, we'll call this point here x2, y2. So to find M, we add x1 and x2 and divide by 2, and we add y1 and y2 and divide by 2 to give us our coordinate pair. Okay, so the point M is easily found like that if we know the coordinates of each of the points, each of the endpoints. Okay, have a go yourselves. Pause the presentation and give it a try. So it was just applying the formula, so hopefully you were successful. You should have ended up with this coordinate pair here. If you weren't, if you struggled with it, then go back over it and make sure you know it, because you really do need to know this stuff so we can move on. So the length of a line joining 2 points. Well, we'll work with the same 2 points. And hopefully you'll recognise what's going on here. We've worked out this length here. We can see it's 3. We've worked out this length here, which we can see is 5. Using Pythagoras' theorem, the square root of the sum of the squares of the two smaller sides gives us this length here. Or in other words, the sum of the squares of the two smaller sides gives the square of the hypotenuse, which is what AB is. To find out the length of AB, we then square root the result. So we've got the square root of 9 plus 25, which gives us root 34. We'll recognise this as being a surd from the work we've done in the previous couple of lessons, and there's not a lot we can do with that surd. There's no square numbers that are factors of 34, so we would leave it like that. So, in general terms, if we make our coordinates at A, x1, y1, and our coordinates at B, x2, y2, then to find the length, it's the difference in the x coordinates x2 minus x1 for this length, and the difference in the y coordinates y2 minus y1 for this length. Using Pythagoras' theorem, if we square them both and add them together, we get the hypotenuse squared, we get AB squared, and then square root to find AB. So for example, if we're trying to find the length of the line joining the points 4, minus 3 to minus 1, 2, we put the difference in our y values and the difference in our x values into the formula. So x2 is minus 1, x1 is 4, so we put that in there, y2 is 2 and y1 is minus 3. Work it out and we get root 50. We can simplify 50. 25, which is 5 squared, goes into 50. It's 25 times 2, so we simplify that to 5 root 2. Okay, have a go at this. If you're successful with this and you were successful with the previous one, finding the midpoint, then you should be about ready to move on. So pause the presentation and have a go at working out the length of the line AB. So here's the solution. Hopefully you were successful. 16 goes into 32, so we can simplify that to 4 root 2. So to summarise, we have this equation to find the midpoint, this equation to find the length of a line.